right. Welcome back, you math rock stars. Today, I'm excited that you're here because we are going to talk about circle graphs. This should be a good time, should be very circular, should be flowing in a roundabout manner. Puns, anyone? Hey, why is a baseball team similar to a muffin? Because they both depend on the batter. Muffin batter, baseball batter. Hey, all right. Well, let's rock and roll. All right. So today we're going to organize and represent data using circle graphs. That's the big goal. Right. So we're going to take data, turn it into a circle graph, and we're going to be able to analyze it, observe it, draw some conclusions with it. It's going to be a good time. All right. So we have some vocabulary. So let's dig into that. First of all, I just told you we're going to organize a circle graph by using information. Well, that information is called data. So all data is a collection of information gathered by observation, questioning, or measurement. So whatever the situation is that you're trying to solve or you're trying to figure out or collect information about so that you can put it on display in some form of a graph is called data. So like this one, how many animals are there on the farm? So when they went around and counted the animals on the farm, they collected data. That's what data is. Okay, categorical data is the same thing. It's the information that you gather. However, it's when the data can be divided into very specific groups. Like for this one, all the data is broken into categories by color. So they asked this group, I like yellow, I like red, whatever it might be. The data is collected into categories, and so it's called categorical data. Next is frequency. So when I'm collecting that data and I'm going out and I'm trying to figure out whatever it is, I'm collecting tally marks, or I'm finding out how many people in the class like yellow, and it might have been 5. 5 is the frequency. How many times did we score 4 goals? Well, we scored 4 goals 4 times. That was the frequency. How often? The number of times a particular event or item appears in our data. And finally, circle graph, which is kind of the big thing we're talking about here. It's really just a circle that is divided into data. So it's divided into pieces. And I want you to look at that and kind of look at it as like a pie. These are actually also called pie charts. People, because it looks like each piece of data that they've collected is turning into a piece of pie. All right, so all it is, each section represents a percentage of the total. So the big thing to understand about a circle graph is the circle represents all the data you collected. Okay, and then each piece of the circle or each piece of the pie represents a part of the data. For this one, the part that liked comedy. For this one, the part that liked sci-fi. Okay? All right, so let's talk circle graphs. Often we do some research on a topic or issue, and then we display that data so decisions can be made. All right, so you'll see it a lot when you're watching the news or you're looking at a magazine or if you're online reading an article. It seems like there's always some piece of data that supports whatever the article's about, and they put those into graphs and a lot of the time. Okay, and so there's a lot of different ways to do it. There's bar graphs, there's line graphs, there's pictograms, there's tons of different graphs, and there's more and more creative way that they're making graphs every single day. But today we're going to talk about the circle graph, okay? So these are just some examples of circle graphs based on some information that people were collected that I found on the internet. Vegetables, the amount of people that chose vegetables. Here's their favorite sport. You can see like over for this one, their favorite sport looks like they have 3 categories that are the same. Favorite pizza topping, overwhelmingly, the advantage was to pepperoni. Number of students that like football, that like badminton, whatever that might be. So we're just going to work on making and developing and analyzing circle graphs. So what are the qualities of a circle graph before we get into that? Well, they often show percent or frequency. So just like those ones we were just showing you, they're showing a percent of the kids who like football or how often um, a certain thing happens, and that's what frequency comes into play. They help us quickly see what category has the highest frequency. So remember that one I said pepperoni was clearly the biggest category? That's because it was the biggest piece of pie, which means that is the one with the highest frequency when we collected data. Okay. Next, they're not great for showing data with a lot of categories. So think about that circle that you're looking at, and most of those circle graphs that I just showed you had 4, 5, or 6 categories. Typically doesn't go much bigger than that. You might get 7 or 8 categories, but The danger with getting bigger than that is all of your pieces are going to be so small, because the more categories you get, the more pieces of pie you get, and the smaller they'll have to be, and it'll be confusing to kind of read. Okay. And when we're looking at circle graphs, we really want to pay attention to our benchmark fractions and percents that we understand really well. And when you think about benchmarks, it's just things that we, without having to do any like calculating or math, that we know how to figure out in our head. And like 50% and half is like that easiest benchmark, right? Half of something, half of a class of 22 students, half of it is 11. Half of an apple, slice it down the middle. So let's dive into those just a little bit real quick. So for example, that half, when we're trying to figure out how to make a circle graph, we know what a half is. It's when we cut something in half. So we literally put a line right down the middle, because it's a half means there are two pieces. And when we say 1/2, the top tells us how much of it we shade in, or what part are we talking about. So that's 50% or a half. All right. The next one we show is 3/4. And so the reason why this is a benchmark is because we use fourths a lot when we deal with math. Even from the earliest grade levels, we start to talk about fourths. You think about a dollar, what is a dollar broken into? Quarters. And quarters are fourths. Okay, so when we're talking about 3/4, we're going to break our circle into 4 parts, because that's the amount total. And then we're going to shade in 3, because those are the parts we're dealing with. The bottom is how many we have in all. The top is what portion of the whole we're talking about, the part. Okay, we can do one more. We can say 1/10. All right, and we talk about tenths again, going back to dollars. If we break something into tenths, we're talking about dimes. All right, so when we think about this, we have to break it into 10 categories, all right, or 10 sections. So we have 10 sections in all: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and how many of them do we want to shade in? We want to shade in one of them. All right, and there is our 1/10. Okay, so just a little bit more practice dealing with these, because then we have to make our circle graph, right? If you have a fraction as a data point, you break the whole circle into the total pieces. So when we have a circle and it's 1/8, we're going to break that whole circle into eighths. Okay. So if you have a number that's an even number, it's kind of like you can start off by just saying, all right, let's 8. So let's cut it in half first. Okay. So there's our half. And then we can cut those halves in half by going the other direction. Now what do we have? Fourths. And then if we cut those fourths in half, what do we have? We have eights, right? Because it's 1, 2, 3, 4, 5, 6, 7, 8. And that's kind of what we're trying to accomplish here. So once you cut them into eighths, what are we going to do? All right, now we're going to have to color in how many? We're going to have to color in one of them. All right, and so when we do that, I'm just picking a different color. Let's go green. And here is our 1/8. Cut it into eighths and then shade in 1. Okay, so now we have 2/6. All right, so now we have 2/6. Let's go ahead and break that into 6. All right, so we have an even number. Okay, so we know we can cut it in half right off the bat. So I'm going to go ahead and do that. Let me pick a different color, because yellow does not show up so well. I can go here. Okay, so there's my half. And now I got to have 3 on each side. So if I go this way, that's not going to work. Okay, you have to play the game of figuring out how many I can make go on each side. All right, so let's start that over. If I go cut it in half, whoops, if I cut it in half, okay, now I need to cut each side into thirds. So there needs to be 3 over here and 3 over here. So I can say 2, 2. All right, 1, 2, 3, 4, 5, 6. Now I admit that is not pretty. All right. So when I cut it into 6, then I need to shade 2 of them, right? Shade it in. So let's go to the next one. Same thing with percent. Okay, we have 33.3%. And we should know, this is a benchmark again, we should know by now that 33 1/3 represents 1/3, right? So we need to cut this into 3 pieces. So now we just go like something like this, and you can play with it. That's why you have pencil and paper, and you can kind of play with it to see how do I turn it into 3 parts. It does not have to be perfect. The goal is for it to be close, so that we can understand what we're trying to draw. All right, so let's go ahead and make one, right? So let's say we've collected data in our neighborhood on their choice, the movie to watch for an outdoor movie night, okay? And so I went to 50 people, and they all responded to the question. What we found out is this is the data. Half of the people chose Lion King, 1/10 of the people chose Princess Bride, 25% chose Frozen, and 15% chose the Lego movie. So let's make our circle graph. All right, so let's turn the data into a circle graph. So we have a circle, and the circle represents all of the information. So what it's representing is all 50 people. That's key, right? Now, now we just break it into parts. So we know we have the Lion King, and this is one of our benchmarks. It's half, so that's pretty simple. Cut in half and put in our Lion King. Okay, so that's 50% of the data. All right, that's one half of the information. We can go to another one we like. I like Frozen, the movie, and the fact that it is 25% because that's a benchmark. That's one that we understand. Benchmark is 1/4. So now we take our thing and we have 1, 2, 3, 4. See how we broke it into fourths or 25%? And when we do that, now we can fill in one of them. Has to be a new spot. You can't double up on something that's already been covered. So that represents Frozen. Okay. Now we've got a little bit of a tricky situation because we have tenths and we have 15%. What percent of the whole is still available to us? If this was half or 50% and this was 25%, what is left over? And this is like a trick for you guys and really will be helpful. It's 25% is left over because it was 50 and 25 is 75% and a whole equals 100%. So what's left over? 25%. Okay, so that becomes an important clue for us. So now we can take Princess Bride and we can say, we're going to deal with 1/10 of what's left over, okay? So we turn it into tenths, do those lines again. You shade in one of them because one of them is Princess Bride. You label it, and then here's where it gets neat. Now we have 15%. It's the only thing left. It's all we have left. We don't need to go doing anything different other than just say, if I've already filled in everything else and this is what's left over and this is my piece that's left over, you just fill it in and label it. So there's our Lego movie. Let's try another one. Okay, now we're collecting information on kids' favorite animal at the zoo. We know that we asked 80 kids, and now our graph is made. Let's analyze the graph to figure out what we're going to do with it. Okay, so here's a couple questions. All right, how many kids chose penguins? Well, penguins is right here. And a lot of people would say 50. They would jump in and say, oh, 50. No, 50% of the kids that were asked chose penguins. How many kids were asked? 80. What's 50% of 80? Well, that would be 40. Half of the kids chose penguins. So that would be 40. Another question would be, how many kids chose otters? Well, 10% did. Okay, 10% of 80. So 10% of 80 is, we break 80 into 10 groups, right? And that gives us 8. Okay, so there would be 8 that chose otters. How many chose pandas? Well, pandas, let me erase some of this stuff on my screen. Pandas is 25% of the total. Penguins was 50% of the total. This told us 40. And doesn't it look like, isn't 25% half of 50%? Yes, it is. So what's half of 40? It's 20. Or you could have just said, what's 25% of 80? It would give you the same thing. And how many kids chose frogs? Well, if we said this was 40, and we said this was 20, and we said this was 8, how many have we done so far? 40 plus 20 is 60. 60 plus 8 is 68. How many kids were asked? 80. Does this graph represent all the kids? Yes, it does. So what is 80 minus 68? And that equals 12. So 12 kids chose frogs. Okay. Arya asked 40 of her classmates their favorite Marvel character. Boom, there it is. She organized the data in this circle. 10 chose Captain Marvel. 10, right there. This is 10 of the kids chose Captain Marvel. 10 out of 40. That's what's key. What does that mean to us? Well, the same number of kids chose Iron Man, Hulk, and Thor. So these are all equal to each other. We don't know what that is yet, but we know that that's our next clue. So use the circle graph to follow the answer the questions. How many kids chose Black Panther? Okay, well, to get to Black Panther, we probably can solve these first, all right? If Captain Marvel was 10, that means that's 25% of the data. And that means over here we have another 25% of the data, right? So if Captain Marvel's 10 and both of these have to be equal, and both of these are half of Captain Marvel, that tells us that Iron Man is 5 and Hulk is 5. You see, because these two cover the same amount of space in the circle as Captain Marvel, so together they have to equal 10. Okay, so let me erase my screen. So we know this is 10, this is 5, this is 5. We also know that Iron Man, Hulk, and Thor all have the same value, so Thor is also 5. And now we can solve this pretty simply. 40 kids were interviewed. It's about their favorite character. 10 plus 5 is 15, plus 5 is 20, plus 5 is 25. So what's left over? 40 minus 25 is 15. So the answer to this one is 15 kids chose Black Panther. Guys, I think you are getting this. I think you're rocking and rolling. And what two characters represent a combined value of 10? Well, you could say these two, right? You could say these two, because 5 and 5. Or you could have said this one and this one. Any two of them cut that together would have given you 10. All right, let's fill in the graphs, or fill in the blanks. A circle graph represents the whole data set, everything that's in the data set. Each piece of the pie represents a part of the data set. Understanding your benchmark fractions or percentages will help you make circle graphs. And also, and finally, and often we use circle graphs to display what? Data we have collected so that decisions can be made by the people who are looking at the data. All right, circlers, let's see what we can do here. Hey, do you guys know why golfers wear 2 pairs of pants? I do. What happens if they get a hole in one? A hole in one of those pairs of pants? Hole in one.